Hello friends, today we are going to cover DP900 second module Explore Data Role and Services. In last session we covered Explore Core Data Concepts wherein we covered identify data formats, different file storage, then how to explore databases, transactional data processing, then analytical data processing. In this session we will cover Explore Data Role and Services wherein we will be covering all the different job roles like data administrator, data engineer, data analyst, and then different data services. Okay, so let's discuss about different job roles in the world of data. So roles involved majorly like managing data, how to control data, and how to use the data. So some roles are business oriented, some roles are related to engineering perspective, some roles are based on complete focus on the research part, and some are hybrid roles which combines different aspects of data management. So if we talk about major roles, those are three major roles: data administrator, data engineers, and data analyst. So if you look here, like data administrator who manages the database, how to manage creating users, add users, assign permissions to the users, then take backup, then restore the data in case of any failure of the data, right? Identify if logs are full or maybe any kind of performance issue in the data. In that case, data administrator help, right? And if we go into deeper, what data administrator is doing, he is overall responsible for the design, implementation, maintenance, and operational aspects of on premises and cloud based data system. So they are overall responsible for the availability and consistency, performance, and optimization of the database. They work with different stakeholders to implement policies, tools, and processes for backup and recovery perspective. And if in case of any disaster, so they recover the data, or maybe any kind of human error, they try to resolve those errors, right? So this is entire work is done by database administrator, right? And if we talk about data engineer, what data engineer is doing, so a database administrator is ensuring that data is there, right? And there is no issue in the data, and also taking care of permissions. Now data engineer is he data engineer need to provide some processing logic, right? Architecture perspective. And data engineer manages complete infrastructure processes for data integration across the organization. Suppose data is coming from different data sources. Now data engineer task is to take the data, integrate the data if required. Data engineer does data cleaning, data governance perspective. Data engineer create pipelines for processing, for maybe transferring the data, or maybe transform the data into more by adding some calculation into more understandable form, right? So data engineer, if you think about, he works on pipelines creation, processing perspective, or integrating the data. It collaborates with different stakeholders to design and implement data related workload. Data related workload includes like data ingestion pipeline, cleaning, transformation, data storage for analytical perspective, and they use different varieties of data platform technologies, including relational, non-relational, all those. If you see that in currently we are working on big data technologies for fast processing, different storage things we are looking into for easy to access the data, right? So that entire architecture designing and architecture implementation for data processing perspective, data engineer takes care. Data engineer is responsible for ensuring the privacy of data while doing any transformation, or maybe for doing any processing. So that person has to take care of privacy. So data engineer owns the management and monitoring of data pipelines to ensure that data load perform as expected, and data engineer ensure that entire processing is as per the expectation, and it just cleans the data and process the data for data analysis perspective further to data analyst, right? Now data analyst, what is the role of data analyst? Data analyst explores and analyze data to create visualizations and charts to make decision. So data analyst enables business to maximize the value of their data asset. Now data has been identified, some KPI metrics have been identified. Now how this data or these KPIs are helpful for business perspective? This is entire analysis work is done by data analyst. They are responsible for exploring data to identify different trends and relationships, designing and building analytical models, and enabling advanced analytics capabilities through reports and visualization. They understand the different trend of business, right? And based on that, they can identify that what was the problem in overall trend analysis in the past, right? And that is helpful to think about or brainstorming for the further increasing the business. So data analyst is overall look into the process data and check the pulse of business, right? So this is again like three different roles, but this is based on the organization. Sometimes medium level organizations, in that case data engineer itself doing data administrative work, or maybe in some organization data engineer and data analysis work is clubbed and done by one person. So such type of hybrid kind of thing happens based on the organization. It's not hard and fast rule that different persons are taking care of different roles. So next, coming to identify data services in Microsoft Azure, it has many services to support cloud solutions, including transactional and analytical data workloads. Let us understand all the services. In Azure SQL, we have a family of relational databases solutions, out of which one is Azure SQL, which is fully managed platform as a service database, which is hosted in Azure, right? So it's entire platform given. Then second is managed instance. Third is SQL on VM, right? So if suppose we talk about one by one. So first one, we are in Azure SQL database. We have a single database, right? We have option of having single database, or maybe we can have elastic pool. So in one of my video, this is fully explained like what is elastic pool, and its practical has also been given there. So I'm repeating here again that in elastic pool, what is benefit of elastic pool actually? Suppose we have to have multiple databases, right? And we want to share the, or maybe share the resources in different databases. In that case, we can choose option elastic pool. So it solves the problem by ensuring that databases get the resources always, and those resources are in shared mode so that cost will not be impacting, right? So simple resource allocation to multiple databases, right? So based on like scale up, scale down, based on that, Azure automatically manage the resources in between that. So there is option of like elastic pool, single database, database server, migration, everything we can do in Azure SQL. But in this case, migration is hard, right? And few SQL Server features are not available. Sometimes if suppose we have to migrate from on-prem to Azure SQL, sometimes we cannot directly migrate. Some features, since some features are missing here, so we cannot replicate, or maybe we cannot migrate entire SQL database. In that case, some features or some objects we cannot transfer, right? So we face some problems in this case. So backup and patches are managed in this case. Database up to 100 terabyte is supported, and up to 99.995 availability is there. So if we see like exact difference, if you see that in Azure database, if we see that we have yeah, in Azure SQL database, we have built-in backup, patching, recovery in options already available there, that is built in. Then it's having ability to assign unnecessary resources to individual databases, and it's having built-in advanced intelligence and security feature as well. And if we look into other option, Azure SQL managed instance, in that this is hosted instance of SQL Server with automated maintenance. It allows more flexible configuration than Azure SQL DB, but with more administrative responsibility for the owner. So in first option, there was no administrative responsibility. Users' responsibility is not there for administration perspective. But in managed instance, if you see, this is best for migration to cloud. Elastic pool feature is there. It maintains database server. Migration is hard, and few SQL servers features are not available in that, right? And backup and patches are managed, and database up to 100 terabyte is allowed, and up to 99.995%. So in this particular option, it's also having built-in backup and patching and recovery options. and it's having private IP address we can have within Azure Virtual Network, and built-in advanced intelligence and security features are available there, right? And its maintenance is configurable, right? Now, next coming to SQL VM. SQL VM is VM with an installation of SQL Server. It allows maximum configurability with fully managed responsibility. In case of like migration, in this case, it's almost, if you see, best for migration to cloud. If we have lots of objects there in on-prem SQL Server, right? And if you want to exactly migrate data to cloud, then in that case, this is best for migration to cloud. It's having lift and shift option. It can be moved without any changes, right? And it can choose when to start maintenance, patching, change the recovery model. These things are configurable there, and we can modify. So this is highly customizable, and in this case, expected downtime would can be there while making changes to storage or CPU. And in other two options, downtime is not there. And its storage is up to 256 terabyte. It has more storage space, and availability is up to 99.99%. So if you see overall in SQL Server on Azure VM, we have full control over the SQL Server engine, right? And it supports all the on-prem capabilities. And if you see that it is in this case, it's easy to migrate the data, and also it's having private IP address within Azure VM. So another point is in SQL VM, we have to take care of manual or automated backups. We can set automated backup as well, and here we need to implement our own high availability solution. Downtime is also there. So few good things and few negative things are also there, because downtime would be there, right? If there is no, if suppose we in our solution we don't require downtime, we have to be fully available, then we have to choose other options. Or maybe in any case, if we need to do migration, SQL Server migration, and it's having lots of data objects, in that case we choose SQL VM. So based on our requirement, based on our different requirements, we use different options. Another good thing is in SQL Server on Azure VM, sometimes we need to have application which run partly on the cloud and partly on the on-prem, right? For example, suppose you can extend your on-prem network and Active Directory domain to the cloud via Azure Virtual Network. So in that case, we generally use Azure VM option, right? And if suppose in any case, if suppose we need to have like on-prem application need to access data in Azure SQL database, right? And database is already there, then we use Azure SQL database. And sometimes we need to have connectivity with on-prem environment using Azure Express Route or VPN gateway. In that case, we choose Azure SQL Managed Instance. So based on our requirements, we choose different options. So database administrator typically provision and manage Azure SQL database system to support line of business application that need to store transactional data, right? And if we talk about database engineer, then data engineer may use Azure SQL database system as source for data pipeline creation, or maybe it can have multiple sources and creating Azure pipeline or data pipeline using ADF or other options, right? And store the data by using different solutions, and perform extract, transform, and load operations to ingest the transactional data into an analytical system. Then data analyst may query Azure SQL databases directly to create reports, or maybe sometimes like we can process the data. Maybe we can have some calculation for the for data analysis perspective, and that calculation we store in different Azure SQL database, or maybe in some other storage, and then data analyst will access data from there and combine the data from wherever required, and then this data goes to the visualization, maybe in Power BI or whatever visualizations we are using for generating the reports. So, or maybe some statistical for statistical analysis, we can use some Python or maybe R. So wherever we need to do further processing for analysis perspective, so that will be done by the data analyst. Okay, so next coming to Azure databases for open source relational databases. So in this we are covering like in managed services, we have multiple options for databases like Azure database for MySQL. So this is simple to use open source database management system that is commonly used in Linux, Apache, MySQL, and PHP. So here we need to just understand like what is the purpose and how what is the purpose only. for different databases solutions. And only just this theory would be here, and in exam we can get some questions related to like what all data sources we have for the in Azure database, right? What all options we have, like PySQL, MariaDB, PostgreSQL. So this way, MariaDB, if you see, this is newer database management system which is created by the original developers for MySQL, right? So this database engine has been rewritten and optimized to improve performance. So if you see, this is compatible to Oracle database, right? And another popular commercial database management system. Third is PostgreSQL, and this is hybrid relational objects database. You can store data in relational tables, but a PostgreSQL database also enables you to store custom data types, right? Which is non-relational properties. So overall, if you see, then third one, PostgreSQL is non-relational properties. MariaDB is compatible for Oracle, and MySQL, this is commonly used in Linux, Apache, MySQL, and PHP. And with Azure SQL database system, open source relational databases are managed by database administrator to support transactional applications and provide data source for data engineers building pipelines for analytical solutions, and data analyst creates reports. So this is the overall, if you see, open source relational databases and how we use that with different roles. So next, coming to Azure Cosmos DB. So Azure Cosmos DB is a global scale non-relational database system. It supports multiple applications, programming interfaces to store and manage data as JSON document, right? So its format is JSON document wherein we store data in key value pair, right? And column family pair or graph. These are different ways. So in some organization, Cosmos DB instances may be provisioned and managed by database administrator, and software developer manage NoSQL data storage as part of the overall application architecture. Data engineers need to integrate Cosmos DB data sources into analytical solutions that supports modeling and reporting by data analysts. So next, coming to Azure Data Factory. So Azure Data Factory is an Azure service. It enables to define and schedule data pipelines, right? And in Azure Data Factory, we can use any language, like you can use big data platform like Spark, Scala, Python, and any kind of script you can write in Azure Data Factory. And in this particular case, if you see that we can create a pipeline, step-by-step process, right, for processing perspective. And this can be used to transform and transform the transfer and transform the data. We can integrate pipelines with other Azure services, or maybe we can have interaction with on-prem as well, right? And this is to ingest the data from cloud data stores, process and data using cloud-based compute, and persist the results in another storage. So Azure Data Factory is used by data engineer in case of any failure in the pipelines. So data engineers set up some automation for monitoring perspective, and accordingly they take necessary action in case of failures, right? So they take care of processing part, monitoring of pipelines, and then ensuring that data is stored whatever required by the data analyst. Then next, coming to Azure Synapse Analytics. So Azure Synapse Analytics is a comprehensive unified data analytics solution. It provides a single service interface, right? And for multiple analytical capabilities like pipelines, SQL, Apache Spark. So based on like pipelines is an Azure Data Factory, SQL wherein database would be there, and Apache Spark is an open source distributed data processing system. It supports multiple programming languages and APIs. Like we are in Apache Spark, we are writing code in Spark.NET, we are writing code in PySpark, then Spark Scala. So different combinations we can write here, like code we can write here. And then Azure Synapse Data Explorer, this explorer is just like a high performance data analytics solution which is optimized for real time querying to log and telemetry data using Custo query language, right? And so if you see that data engineers can use Azure Synapse Analytics as a unified solution, and it combines data ingestion pipelines, data warehouse storage, data lake storage as a single service. And this is helpful in that case because all the combination of services are there. Based on that, this is just like an integration platform wherein we are integrating all the services and accordingly using them. and data engineer take responsibility of that entire integration part, how to combine, how to provide the solution. And data analyst can use SQL and Spark pools through notebooks, interactive notebooks, and explore and analyze the data and take advantage of integration with services as Azure Machine Learning, Power BI to create data models and extract insights from the data. Okay, so next coming to Azure Storage. Azure Storage is core Azure service that enables you to store the data. Sometimes if you see that we store data in different files, right? In blob container we store data, or maybe we can do some processing and store data into tables form. So these are the three different options in Azure Storage. One is blob container. Blob container is used to store the binary files, right? This is scalable, cost-effective storage for binary files, like images or maybe videos you can store here. Then second is file share. So this is network file share. Generally we use in corporate networks, and we can store files here. Then third is tables, wherein we have key value storage for applications, and from where applications can read and write data values quickly. So data engineers use Azure Storage to host data lakes. Data lakes in like if you see blob storage with the hierarchical namespace that enables files to be organized in folders form in a distributed file system. So maybe in my upcoming videos, you will see the demo as well for Azure Storage. So next coming to Azure Databricks. So Azure Databricks is an Azure integrated version of the popular Databricks platform. And in this we combine Spark data processing platform with SQL database. So generally we write Spark notebooks and execute here. And this is an integrated management interface to enable large scale data analytics perspective. So data engineers use existing Databricks and Spark skills to create analytical data store in Azure Databricks. And then data analysts use notebooks in Azure Databricks to query and visualize the data in easy to use web-based interface. It can be Power BI or maybe some other web-based interface. So next coming to Azure HD Insight. HD Insight is an Azure service which provide Azure hosted cluster for popular Apache open source big data processing technology. It contains Spark, Hadoop, HBase, Kafka, Storm. So we can just in this particular module we have only introduction. Like if you see Spark, we can write Spark notebook for processing perspective. It handles distributed data processing as well, and we can use multiple programming language, right? For example, Spark with Scala, or maybe PySpark with Python we can do, right? And Spark.net also we are doing somewhere. So Apache Hadoop is a distributed database, a distributed system. It uses MapReduce jobs to process large volume of data, and MapReduce jobs can be written in Java, or it can be abstracted by interfaces such as Apache Hive, which has API based interface, right? Then Apache HBase, this is open source system for large scale NoSQL data storage. Apache Kafka, this is just to for the message broker for data stream processing. Apache Storm, this is open source system for real time data processing, right? Real time, whenever suppose in some organization some data is coming at the same time, we need to process the data. Instead of batch processing, we are doing real time processing, right? So wherein it follows the topology of spouts and bolts. So data engineers can use Azure HD Insight to support big data analytics workloads, which depends upon the multiple open source technologies. Then next coming to Azure Stream Analytics. So Azure Stream Analytics is a real-time stream processing engine. It captures stream of data from an input, apply query to extract the data and manipulate the data, and then write the results for the analytics perspective. So data engineers can incorporate Azure Stream Analytics into a data analytics architecture and capture the streaming data for ingestion, and then for an analytics perspective, real-time visualization would be there. So next coming to Azure Data Explorer. Azure Data Explorer is a standalone service. It offers same high performance querying of log and telemetry data as Azure Synapse Data Explorer runtime in Synapse Analytics. So data analysts can use Azure Data Explorer to query and analyze the data and include timestamp attribute, which is helpful for the IoT perspective, right? So next is Azure Purview. So Azure Purview is not that old. So Azure Purview provides a solution for enterprise-wide data governance and discoverability. If you see that Azure Purview creates a map of data and track the data across different data sources, and also it enables us to use for data analysis and reporting perspective. So data engineers use Purview to enforce some data governance there, and also ensure the data integrity is there, which is required for the analytics perspective. Next, coming to Power BI. So like mostly this is very useful tool. So by using Microsoft Power BI, we can access data from different sources and create visualization of the data. We can have some trend of data, month on month trend, or year on year trend, and we can identify some KPI metrics and create visualization here for the analysis perspective. So it delivers through web-based reports, and also uh, we can also have reports in Microsoft Azure as well, right? It can be you can use Power BI desktop or Power BI service. Both options we can use in Power BI. So this way we have completed module 2, wherein we covered all data roles and services, and major services for data engineering perspective, data administration perspective, and data analytics perspective. So we will in next video we will cover next module for DP900. Thank you. Thanks for watching this video.